Welcome to Crystal Clear Chemistry channel. In this video, I am going to explain the part 2 of nomenclature and classification. In order to crack either JEE mains or NEET exam, let's strengthen our basics through this channel. And I have already uploaded the replica questions of JEE mains from equilibrium and ionic equilibrium chapter. Just go through the playlist, you can find. Okay, so without any delay, let's get into the topic, today's topic, that is nomenclature and classification part 2. If we consider the carbon atoms, there are four types of carbon atoms depending upon the atoms that are attached to a particular carbon. We know already that if we consider the carbon, there are four bonds must be there around the carbon. Among the four bonds, if only one atom is carbon, then the type of carbon atom is primary carbon. If one carbon is attached to one and only one carbon, then that carbon is called primary carbon. Suppose if that carbon is attached to two carbon atoms, for example, if we consider this example and if we consider this green color carbon, it is attached to two carbon atoms, hence secondary carbon. And all these pink color ones are primary, right? And let's check this yellow color carbon. There are three carbon atoms that are attached to this particular carbon, hence a tertiary carbon atom. And if we consider this carbon, it is attached to four other carbon atoms and hence it is quaternary carbon atom. Okay, so a simple classification based on the number of carbon atoms attached to a particular carbon. Okay, now let us see what is the relation between hybridization versus the carbon. Suppose if we consider the carbon, if it attaches to four sigma bonds, if there is no multiple bond to that particular carbon, then we can say it is undergoing sp3 hybridization. From the chemical bonding chapter, it is clear that whenever double bond is there, the carbon is undergoing sp2 hybridization, and whenever triple bond is there, the carbon as it is undergoing sp hybridization, it is able to form triple bond, right? So single bond sp3, double bond sp2, triple bond means sp hybridization. Now check this example. CH3 attached to CH, single bond, so sp3. There is a double bond sp2 sp2. This is also sp2, this is also sp2. And if we consider this particular C double bond O, as there is a double bond, definitely it is undergoing sp2 hybridization. Double bond is there. Okay. Now listen carefully. There is another type of sp here. So instead of triple bond, if a carbon is attached to two double bonds, then that time also we can call that carbon as a sp hybridized carbon atom. So CH2 double bond C double bond CH2, this is sp hybridized carbon atom. Okay. Now if we consider the number of atoms that are attached to the carbon versus hybridization, if four carbon atoms are attached to a particular carbon, four atoms are attached means definitely all are sigma bonds and hence sp3 hybridization. If they are attached means definitely one must be double bond, hence sp2. If only two are attached means definitely one must be triple bond and hence sp hybridization. And we know already about the bond angles, 109.5 degrees, 120 degrees, 180 degrees. And what about the geometry? If the carbon is undergoing sp3 hybridization, it's tetrahedral. If it is undergoing sp2 hybridization, then it is a trigonal planar. And if the hybridization is sp, then we can say that it is a linear geometry. It attains linear geometry. And whenever there are sigma bonds, only four sigma bonds, there won't be any pi bonds, and hence for sp3 0, 1 and 2 for sp, the number of pi bonds. Automatically we can write even the number of sigma bonds also here. So conclusion here is, if we consider all the single bonds, if the carbon contains all single bonds sp3, two single one double sp2, one single one triple or two double side, then it is of sp hybridization. Okay, now you can clearly check the examples here. See, For example, if we consider this particular carbon atom, double bond is there, sp2. Two double bonds are there, sp. One double bond is there, sp2. This is sp3. And what about this one? sp2. And if we consider this particular double bond O also, it is undergoing sp2 hybridization. And you can check even more examples here. And one more important point here, if the carbon attaches to N nitrogen through the triple bond, then that time also we can say that it is a sp hybridized carbon atom. Okay. Now, if next one, let's move to the next one. Whenever there is a sp3 hybridized carbon atom single bond, then we can say that its bond length is 1.53, and sp2 carbon atom bond length, double bond, as double bond is there, 1.33. If triple bond is present, then it is around 1.2 angstrom units. Here if we consider, this is the shorter bond and hence strong bond. Okay, and if we consider 1.53 angstrom units, it is longer as well as weak when compared with the triple bond. Okay, so you can clearly see here, single bond is weak, hence 88 kilocalories. Triple bond is strong and hence 200 kilocalories. Okay, now listen carefully, very important point here. Whenever there are three different types of hybrid orbitals like sp3, sp2 and sp, orbital size we can easily predict that sp3 greater than sp2 greater than sp. But if we consider the electronegativity, it is directly proportional to the s character. Directly proportional to the s character means sp hybridized carbon atom, if we consider, it is of 50%. It is of 50% the s character, and hence it's the sp hybridized orbital has more tendency to attract the shared pair of electron towards itself when compared to sp2, when compared to sp3. Okay, this is about the electronegativity versus the hybrid orbitals. Okay, and here I wanted to write one more important type of problem, one model I want to discuss, that is about the ratio of the number of hybrid orbitals and unhybridized orbitals. Okay, so let me take a slide here. Yeah, just listen carefully now. Suppose if we consider the benzene if we consider, and this is sp2 hybridized carbon atom, sp2 hybridized carbon atom, sp2, sp2, sp2 and then sp2. How many hybrid orbitals are formed from one sp2? If carbon atom undergoes sp2 hybridization, sp2 means s1 and p2, total of 3 hybrid orbitals will be formed. Like this, how many such hybrid orbitals are there? 6, right? 6 sp2 hybrid orbitals. So 6 into 3, 18 hybrid orbitals, right? There are 18 hybrid orbitals in this particular structure. Now I want to calculate the unhybrid orbitals. If we consider a carbon after undergoing sp2 hybridization, one p orbital left. That p orbital of one carbon atom, if we consider, as there are 6 carbon atoms, 6 such p orbitals are unhybridized. So you can take 6 p unhybrid orbitals. Along with that, if we consider the hydrogens here, each carbon atom, as it is already attached to the 3 bonds, 1, 2, 3. That means each carbon atom has a hydrogen each, right? So if we consider that particular sp2 hybridized carbon atom, there are hydrogens, single hydrogens with each carbon atom. And if we consider the hydrogen, it will not undergo hybridization. In that case, number of hybrid orbitals are 6. So 6p of the carbon and 6 s orbitals of the hydrogen don't undergo hybridization, and hence there are 6 plus 6, total of 12 unhybrid orbitals. And I want to take the ratio here between the number of hybrid orbital versus number of unhybrid orbitals. And here, if I consider unhybrid orbitals and hybrid orbitals, 18 is to 12, that is nothing but 3 is to 2. So 3 is to 2 is the simple ratio between the number of hybrid orbitals and unhybrid orbitals of this particular compound. Okay, one important model. Till here we discussed so far about the basics of organic chemistry. Now we are getting into the classification of organic compounds. Okay, let us see the classification of organic compounds. The existing large number of organic compounds and their ever increasing number has made it necessary to classify them on the basis of their structures. Organic compounds are broadly classified as follows. See, as trillions of compounds are present in the living organism of carbon, or you can say the organic compounds, it's very important to classify them, because we can't study individually each and every compound, right? Definitely there is a need to classify those organic compounds, at least based on their structures. Okay, now classification of organic compounds. Organic compounds mainly divided into two types: acyclic or open chain compounds, and the second one is cyclic or closed chain ring compounds. Closed chain ring compounds are of two types: homocyclic and heterocyclic. See, first if we consider the closed figures, homocyclic homocyclic compounds means, suppose if we consider this particular compound, all are carbon atoms, hence it is homocyclic. But if we consider a particular example like a tetrahydrofuran, this is called a THF, tetrahydrofuran, and here the tetrahydrofuran contains a heteroatom like oxygen, and hence it is called a heterocyclic compound. Now, if we consider the homocyclic compounds, there are of two types: alicyclic compounds and aromatic compounds. We are going to discuss what are aromatic compounds. Those compounds which are other than aromatic are called alicyclic, and aromatic again classified into benzenoid and non-benzenoid structures. One by one in detail we will discuss what they are. Suppose if we consider acyclic open chain compounds, straight chain compounds, there is no ring structure or closure structure or closed figure. Alkenes, alkynes, alkanes, you can say that they are the open chain compounds. Okay, see, if we consider all these examples, they are all open chain compounds and they are not cyclic. As they are not cyclic, they are acyclic compounds. Okay, now what about alicyclic compounds? Alicyclic or closed ring compounds, ring compounds, if we consider, there are see, if we consider this is a cyclic compound, simply cyclic compound, we can call it as a alicyclic, acyclic or cyclic. Instead of cyclic they are saying that it is alicyclic, that's all. Okay, and we already know that the alicyclic are of two types: heterocyclic compounds and homocyclic. If we consider these two comes under homocyclic compounds and these two comes under heterocyclic compounds. Okay, now these two are heterocyclic. And if we consider the aromatic compounds, benzene type compounds, as of now you try to remember that if there is a benzene type structure in the compound, they are called benzenoid aromatic. Benzene is an aromatic compound. And if any compound contains a benzene ring, then we can call that as an aromatic compound. Okay. Now, what about non-benzenoid aromatic compound? See, suppose if we consider this particular example, this is an aromatic compound but does not contain any benzene structure and hence non-benzenoid aromatic compound. Then what about heteroaromatic compounds? This is tetrahydrofuran. This is furan. Tetrahydro means double bonds should not be there. Okay, so this is uh, furan, and this is thiophene, and this is pyridine. All are containing heteroatoms and they are of aromatic compounds. So, if we consider the classification of organic compounds are of two types, as acyclic or open chain or aliphatic compounds. And the other things are cyclic compounds. Okay, in the cyclic compounds, there are two types: homocyclic, heterocyclic. Homocyclic means all are carbon atoms. Heterocyclic means heteroatoms must be there. Here pyridine is the example. Now, in the homocyclic compounds are of again two types: benzenoid aromatic compounds and alicyclic compounds. Okay. Now, if we consider this heterocyclic, again heterocyclic also two types: alicyclic and aromatic. Alicyclic and aromatic. Uh, Aromatic means benzene type compound. Other than benzene type compound is alicyclic, right? Other than benzene compound is called alicyclic. And in the case of benzenoid aromatic compounds, phenol is the example, non-benzenoid aromatic compound, azulene is the example, and alicyclic compound means cyclopropane is the example. Okay, this is about the classification. Now, homologous series. What is meant by homologous series? A group of series of organic compounds, each containing a characteristic functional group, form a homologous series or members of the series, and they are called homologous. In a particular series, the successive members differ by the molecular formula CH2. What does it mean? Suppose if we consider alkanes and CnH2n plus 2 is the general formula of the alkane, and the first member of the alkane is nothing but CH4, and here if we consider the second member, if we want to write the second member, then it must be C2H6. The difference between these two is nothing but CH2, which differ by a CH2 group. Hence, these two are said to be homologous of a particular type of compounds. Here, they are nothing but the alkanes. Okay, and even we can take the third member also here. C3H8 is the third member of that homologous series. Now, naming of organic compounds. There are two types of names. One is common name or trivial name. The other thing is IUPAC name, IUPAC name. Here, if we consider the trivial name system, when the number of organic compounds was less, each compound was given a name based on the occurrence, abundance, or the property. For example, acetic acid, acetone, formic acid, formaldehyde, acetic acid, acetic anhydride, etc. All these are the trivial names, or you can say common names. But when the number of organic compounds are increased, it was very difficult to give each compound and each individual name. So to overcome this, IUPAC introduced a systematic naming system for organic compounds. However, some of the compounds are familiar to us by their common names only. So we need to remember some of the compounds common names, and you can clearly see here what are they. See, this is allene. and this is L-ylene. There is a vinyl acetylene, L-yl acetylene, formaldehyde, acetaldehyde, benzaldehyde. I think you know already all these common names, right? Crotonaldehyde, acetone, acetophenone, benzophenone, formic acid, acetic acid, propionic acid. And if we consider butyric acid, valeric acid, succinic, caproic acid, so all these are different compounds and their trivial names. See, oxalic acid, malonic acid, succinic acid, glutamic acid, and there is an acid called adipic acid. Okay, these are all some of the trivial names of organic compounds. Now let's move to the next part, that is the IUPAC nomenclature. To know what is exactly the IUPAC nomenclature and all, let's check my playlist. You will find it in video 3 as part 3 of classification and nomenclature. Okay, that's all for today. Thanks for watching the video. As I said already, if it really helpful, please subscribe and share to your friends. Thank you.